this lesson, we will be learning how to reduce square root expressions that contain variables. Okay, so anytime we have variables under a radical, we're only going to be working on square roots, not cube roots with variables. So the first thing we want to do is to separate our problem into two separate problems. So for example, if we're learning how to simplify the square root of 12x to the fifth, we want to break it down into the numbers and the letters separated. All right, so the first thing we want to do is reduce the square root like we've been doing. So over here, I'm going to put the square root of 12. And on the other side, I'm going to put my variables. All right, so I'm just going to separate the two and kind of treat them as two separate problems until the end. So reducing the square root of 12, we've done this before. Start by dividing by 2 and keep dividing down until you're only left with prime numbers. All right, and then of course we're going to make pairs because we're finding the square root. Circle pairs. Anything that's in a pair goes to the outside of my radical, and anything like this 3 that's not in a pair stays underneath. All right, so the square root of 12 simplifies to 2 radical 3. So now let's talk about what to do with variables, and I'm going to go through two different methods on how to do this. So if I'm reducing the square root of x to the fifth, I need to first figure out what do I have underneath. X to the fifth is what? It's 5 x's. 1, 2, 3, 4, 5. So method number 1 would be to list out how many of each letter I have. And then keep in mind, since we're taking the square root, we are making pairs, just like we're doing with the numbers. So I'm going to make pairs of x's, and in each pair, cross one of them off. All right, now however many pairs I have goes to the outside of the radical just like before. So if I notice I have 2 x's, and when I represent that, that's as an x squared. Okay, because that's telling me I have 2 x's. And this one little x is left over underneath. Okay, so x squared on the outside, because there's 2 pairs of x's, so that however many pairs tells you your exponent. And then if you have an x left over, it's underneath. Now, one thing to think about with variables is you should never have an exponent left underneath your radical if you're simplifying the square root of a variable. Because if I had an exponent here, like let's say there was a 3, that means I can make more pairs. So if there is a letter left underneath, it should never be greater than one of them. The exponent should never be greater than 1. So you can use that as a check. All right, now the last thing I need to do is just put my answers back together. Anything that's on the outside, for example, this 2, and this x squared from over here goes on the outside of my answer. Anything that was left over underneath this 3 and this x over here just goes underneath next to each other. All right, so this whole thing is my final answer. Keep in mind we write our numbers before our letters. And if we have multiple letters, like we'll see in the next example, we always try to put them in alphabetical order. All right, now before we move on, let's go back and let's take a look at method number 2, because this method of listing out our x's or y's or whatever can become a pain when I have huge exponents, which we'll see shortly. So we're going to take a look at another way to do it. All right, what we can do is we can start and divide the exponent by 2. We're making pairs. Okay, so if I take my x's and I do 5 divided by 2, why 5? Because that was the exponent. And we're dividing it by 2 because this is telling me how many different pairs I can make. I get 2.5. All right, so in our directions it says put the whole numbers outside the radical. That's this guy right here. This is 2. That's telling you how many pairs I made. So the 2 is a whole number, so that's going on the outside. That's my x squared. And then it says if you have a remainder, all right, so it'll be a 0.5. You're not going to get anything else because remember, 0.5 is 1/2. So it's saying I have 1/2 of a pair left over. Well, 1/2 of a pair is only 1, right? So it's telling me I have 1 x left over. So if you get a 0.5, that's telling you you have an x left over under, left over under the radical. If there is no 0.5, it's saying there's no remainder. All of your letters got paired up. All right, we'll explore that further in our next example. All right, so here we have the square root of 12 xy to the 8th. So we're going to separate our numbers and we're going to separate our variables. Okay, so the number reducing the same way we always do. 2 and 6, 2 and 3, make a pair. Okay, so I have 2 square root of 3 for my numbers. Now my letters, we've got 2 different letters here. That's okay. I've got an X and a Y. So right now, this is how I just show my work. You can show it in any way that you want. All right, but so let's take a look. So I'm going to divide every exponent by 2 because I'm making pairs. So the exponent here next to my x is a 1. Remember, if you don't see 1, it's that invisible 1. So when I go ahead and I do 1 divided by 2, I get 0.5. For my y's, when I do 8 divided by 2, I get 4. Okay, so what does that tell me for my letters? First, let's look at our x. There is no whole number. There is no number in front. That says I wasn't able to make any pairs. And when we look at it, that makes sense. I only have one x. I can't make a pair of 2 with only 1. So we have this 0.5 right here. Remember, when it's a 0.5, that's telling you you have one of those letters left underneath. Now, when I look at my y's, here's my whole number right here. It's a 4. That's telling me I made 4 pairs of y. So that's going to the outside of my radical, and that's a y to the 4th. So whatever this whole number is, becomes the exponent. Now, do I have any remainders? Do I have a 0.5 left over? No. So that means there is no y left under the radical. And if I were to do the listing method, this makes sense. 5, 6, 7, 8, because I have 1 pair, 2 pairs, 3 pairs, 4 pairs. So I have 1, 2, 3, 4, y to the 4th without any left over. Okay, so just showing the other way why it works. So whole numbers become the exponent on the outside. 0.5s tell you have one of that left over underneath, and we don't put an exponent next to it. All right, C. Now look at this one. We've got 23, we've got 52 as our exponents. We don't want to be listing those out. That's going to take a long time. So we want to use our little trick here. So let's go ahead and let's separate. Okay, so the 160, start by dividing by 2, 2, 2, keeps going, 2, and 2. All right, so what do I've got? I've got 2 2's going to the outside, so 2 times 2 is 4, and left over underneath is the 2 and the 5. So 4 radical 10 is my numbers. We'll come back to that. Oh, you know what I just realized? I forgot to write my final answer here. I'm so sorry. Remember, we do need a final answer that combines everything. So on the outsides, I have the 2 and the y to the 4th. And underneath, I have a 3 and an x. So just make sure you do that final step. Sorry about that. Okay, back to our current example. All right, so we reduced our numbers and got 4 square root 10. So over here, we've got some letters to take a look at. We've got a W, an X, a Y, and a Z. Okay, so for the W, I am doing 1, because that's a 1, divided by 2. And that gives me 0.5. For the X, I'm doing 23 divided by 2, which gives me 11.5. Okay, so I see 0.5s for both of those, so I know I'm going to have remainders. I'm going to have a W and an X left over underneath. For Y, I'm doing 52 divided by 2, which gives me 26. And for the Z, I'm doing 4 divided by 2, which gives me 2. Okay, so let's go one letter at a time and figure out what's going on the outside and what's going on the inside. So for my W's, I just have a 0.5. I don't have a whole number, so no W's are escaping. But because of that 0.5, that's telling me 1 is left underneath. For my X's, I have an 11 as a whole number. So I know that's going to the outside. And guys, I'm going to leave myself some room because I see there's still other letters to come. So I want to make sure there's space to write those in. All right, so the 11 meant X to the 11th on the outside. Because of this 0.5, that's saying you have 1 X left over underneath. Okay, that's half of a pair. All right, so for Y, I just have the whole number of 26. So Y to the 26th on the outside. No 0.5, so no Y's underneath. There is no remainder. And for Z, I have a whole number of 2. So Z squared on the outside, no Z's left underneath. So then when I go and write my whole final answer, I have 4, X to the 11th, Y to the 26th, Z squared, square root of 10wx. So just make sure after you do all of that work, you include everything in your final answer. All right, and this is what I was talking about when I said we want to try to keep things in alphabetical order. Notice I wrote x, y, z. All right, let's take a look at our next example. So we have the square root of 169 over here. And we have the square root of x, y to the 8th, z to the 13th. All right, so 169 is a perfect square. The only thing I can divide into it is 13 and 13. So remember, when I do that and it's a perfect square, my radical will disappear. Now that doesn't mean it's going to disappear my whole final answer, because I've got to figure out what's going on with my letters to see if there's anything left over underneath the radical. Okay, so we've got x, y, and z. All right, so for my x, it's 1 divided by 2, which is 0.5. 8 divided by 2, which is 4. And 13 divided by 2, which is 6.5. All right, so what does that mean? That means x, no whole number, but a 0.5. So I have an x underneath. Y just has a whole number of 4, so that's on the outside. No remainder. Z has a whole number of 6 with a remainder of 0.5, so I have a z left over underneath. Okay, so when I combine it all together, I have the 13, y to the 4th, z to the 6th, square root of x, z. All right, there are 2 more examples. So what I would like you to do is I would like you to pause the video, try this example on your own, okay? I'm going to pause it as well, so when you press play, the answer is going to show up, okay? So pause the video, try it on your own. Okay, so you can see our work here. Now for our numbers, keep in mind there's that 6 in front, so that's still part of what's going on over here. As I break down the 180, I found a pair of 2s and a pair of 3s. So 3 times 2 is 6, times the 6 that was already out there. That's how I got my 36. All right, and then I saw this little 5, lonely little 5 left over underneath. For my numbers, I just had x to the 9th. When I divided by 2 was 4.5. So 4x is on the outside, a remainder x underneath. And my y's, when I did 16 divided by 2, 8 on the, excuse me, 8 on the outside with no remainder. All right, we have one last example. So same thing, please go ahead and pause the video. Try this on your own. I'm going to pause the video as well and work through it. So when you press play again, you will be able to see the answers. All right, let's take a look. So -3 radical 40, don't forget that negative is part of your answer. Okay, when I break it down, 2 moves to the outside, so 2 times -3, that's how I got my -6, and then 2 and the 5 are left over for 10. On the letter side, 17 divided by 2 gave me 8.5, telling me I have 8 pairs of x's with one little guy left over, and then I have 17 pairs for y's. Okay, so when I combine it all together, -6, x to the 8th, y to the 17th is on my outside, and the 10 and the x are left over underneath. All right, go ahead and bring any questions you have to me, and I'd be more than happy to help you out.